my new car yesterday. A Tesla. So I got it. I had to pick it up in Chicago. So a buddy of mine drove me down there, and it was like in a snowstorm, right? So I get this, and you don't even have to deal with humans when you pick it up. You like get near it and open up the app on your car, on your phone, and then you acknowledge your pickup of the car, and then the car opens. And then you get in, and you have to click a couple of other buttons on the app, and now it's your car.
Is there a key, or is it like?
My phone's my key. There is a little credit card key, huh? Yeah, there is a credit card looking thing that you use initially to like link it to your phone. But what's kind of disturbing and awesome at the same time is pre-installed, because there's this giant screen in the middle. If you look inside of a Tesla, this is a Model Y, there's like you don't have stuff. It's like completely open. You just have a big computer monitor in the middle of it. Pre-installed in this thing is Netflix, HBO. So you have something to do. Yeah, and now, so I opted into the beta, so I have even in town navigation on autopilot. So like I was in my driveway this morning, and I put in Concordia's address, and I said, take me there. And my car backs out of the driveway, drives me to Concordia. I took over once we got on campus to find a good parking spot. I don't know if it would have found a parking spot or not, but I'm waiting for them to release the feature, which is supposed to come pretty soon. It's the 2.0 of their summon feature, where, because right now you can hit summon, and it's called smart summon, where let's say I'm parked outside of the, right now I'm parked outside of the makerspace, and maybe I go and stand by the sidewalk, maybe 800 feet away or something like that, whatever, not right next to it, but near. And I can do smart summon. It'll back out of the spot and come pick me up. But the next version of it is supposed to I can have it drop me off at a door and then go park. And then when I'm done for the day, I can come out and summon it, and it'll come pick me up. And then the next level after that, Model Y. The next level after that is supposed to be, they want to be a competitor with like Uber. So it'll drop me off at work, then go drive people around all day, then come pick me up, making money.
See, I know tractors. I mean, you have some tractors that are, need to have someone with a tractor.
Yeah.
Although I can see this being very scary, because
Well, everything's in beta right now.
Yeah.
Like autopilot on the interstate's not, but this navigate on autopilot thing it'll stop at stoplights. It starts again on green lights. It's the whole rigmarole. It's pretty interesting, but you could play video games on the thing. And there's this car racing game where you use the steering wheel of the car to drive it. So it kind of looks like Mario Kart type thing. And the funny thing is, am I going to be able to do that? I haven't tried yet, but can you do that while on autopilot, while on the interstate? So you're playing this game and you're like, you're crazy turning and stuff in there. He pulls me over. Mr. Gonzalez is buckled in the other seat. We've been watching Criminal Minds. We've been unsubbing during the whole ride. You have bad road rage?
Terrible.
Really?
Absolutely terrible.
I have a British guy, a buddy of mine, who's got that problem.
My mom is from Chicago. She learned how to drive on 90.
Yeah.
And she taught me.
Okay.
And so if anyone does anything considerable not perfect,
You're all over them.
oh yeah.
Just screaming at them through your car where they can't hear you, or you chase them down?
Oh no, I'm screaming, but sometimes my windows are all down.
That's pretty funny.
No, as much as I like a Tesla, I like my stick shift car. So.
I did, when I test drove it, I did try Ludacris Mode, because all the Teslas are electric, so they have instant torque. And if you just slam on the gas, it just blows you back in the seat. Even the non-performance models will. I think it can go, I don't have the performance one. I have a red Model Y. the long range one with the upgraded tire things. What are they called? Forgot what the name of the tire is, but it's, I don't know, they're cool looking black tires they're induction tires. But I think mine goes 0 to 60 in 4.2 seconds. I don't know why I need to go 0 to 60 in 4.2 seconds, because I have audiobooks to listen to.
Well, I mean, that's.
I got priorities.
Well, I mean, that's good because fast acceleration on the highway.
I'm not accelerating on the highway. The car's driving to me.
Yeah. So the car automatically accelerates within 2 seconds on the highway.
It'll change lanes and stuff.
Yeah.
That was scary when it was changing lanes in the snow.
Oh, yeah. Oh my goodness.
Yeah, it was super good.
One of the like difficulties I can imagine with the self-driving cars is being able to detect the lanes with the snow on the road.
But it's like, what's different about it is my previous car had self-driving on the interstate, but it's detecting the lines itself. This car doesn't. Because like this morning when it was driving me from my house to here, my road, in the residential area doesn't have lines.
How does it?
It like finds out where the curbs are and stuff like that. And I think it bisects the road, and then it has like this two blue line path that just kind of figures out that is likely the center of your lane.
That sounds very.
And it detects cars around you, but it doesn't just detect, is it a car? It detects like the size of it. Like you can see what's a semi, what's a pickup truck and things like that. It'll see things like way ahead. Yeah, it's fascinating.
Very like difficult to like actually get into the program for that.
Well, even using it. I mean, I didn't know what I was doing, and there was nobody, there was no human to pick it. I mean, I bought this thing on an impulse for my phone this weekend. I have problems. I did it all from my cell phone.
Yeah, some people gotta really trust these programmers to know what they're doing.
Well, but what I was telling some of my friends this morning when I came home, I watched like a 45-minute video last night on how to use like the whole computer. Everything's done through the computer. Like even like vents and stuff, like for the air conditioning. There's no vents. You go into the computer and you like drag stuff around on the screen to like change exactly where the wind is blowing and stuff. And it even shows like the physics of it going over the steering wheel and things like that. It's ridiculous. Yeah.
Does it, like, have a speedometer on the big screen?
Yeah, it's on the big screen.
What about rolling down windows?
I don't know. I haven't rolled down a window yet.
I mean, is there a button?
That's what I'm saying is I don't know how to roll down my windows. That's what I'm saying. Is there a button? I think no.
Is there not like a lock button? Is it just like on the screen?
There's a button on the door to open the door, but it's a computer button. You hit it and the door, the window goes down like a ½ inch or something like that because it's rimlet, like there's no frame. So I guess that's don't break your window, and then the door just opens. And then you step out and then you shut it and then the window goes back up and you just walk away. The car shuts itself off, it locks, does all.
How do I feel about that?
I think there is a manual release I was seeing in the video. I haven't found it yet, or I haven't looked for it yet, but I'm pretty sure they discourage you using that because then the window won't go down and you could hurt your window. But if you're like, you had to get out and the battery was dead or something, I guess. And it's got a trunk in the front, a frunk, and also a whole thing in the back. So it's like it's an SUV, but it's a smaller SUV. I would say if you are familiar with Honda, it's like a Honda CRV type size.
Yeah, I guess that's the other question I was gonna have. What if you, well, if you're an autopilot, I don't even know how this situation would occur, but if you end up going off a bridge or something like that into like a lake or something.
Yeah, it flies.
Well, yeah, it flies. You have to press a button to roll down the window. How do you get?
Oh, to get out? So if it flies into a lake. I don't know. I think the math for it or all the safety tests show that it's like far better than a human driver, even though it might behave kind of funky sometimes. So like I've seen videos where like this person's on the interstate on autopilot. This is from several years ago, so I think it's more mature now. And all of a sudden, like they're going 70 miles an hour and their car just slows way down. I'm like, what's going on? I mean, it slows to like 30, 20 miles an hour, something like that. And then there's like this 5-car pileup in front of them, but like 15 seconds later.
That's crazy.
Like their car did all the math and stuff and figured out that something bad's going on up there. You haven't seen it with your eyes yet, but the car saw it. Yeah, I don't know. So it's interesting. It's exciting, whatever. But at least now I have, and every week there's like new software updates for the beta. So you get to beta test a new feature while you're like putting people's lives in danger. Yeah, it's great. Yeah, that's my cup of tea.
You give us a heads up before you're on the road.
Well, Mr. Gonzalez is driving half the time.
Oh, gotcha,
Yeah.
I was gonna say, my father's car.
He's not really, one of his strengths is not giving a heads up.
Yeah, I was gonna say, my father's car has a smart device, but not to the extent that you're talking about.
Yeah, so it's cool. At this point, I haven't even figured out all the stuff it can do. So that's going to be this weekend. I might spend some time over here in the mostly empty parking lot of Concordia, seeing how it behaves under different circumstances. Like put it over by the field house and then have it try to pick me up at the circle drive.
I could just use food walking as like,
I saw a video
there's no driver in the car.
of a guy having a Tesla come get him, but there was a cop that was driving by.
Yeah, I saw it. It ran a stop sign, and the cop pulls the car over, but there isn't a person in there.
I was just like scratching his head.
So like, well, who do I give the ticket to? The cop couldn't. So he ended up not giving a ticket, but it was funny.
That's where you're gonna come up with devices where the cop can just take
Well, you
the
don't have a
license
safety
plate and give
procedure.
the ticket to the car.
Yeah, right.
And the owner of the car is responsible for that ticket.
It's true. All right.
You're not turning the screen on.
Good.
I'm like 95%.
No, that-
Well, that's okay. We didn't have anything to share yet, anyways.
no, that is-
But it's still a good. What's our chat here? Okay. So before I start in with stacks and stuff, and like I said, I mean, we do have to end fairly early today, so I can get over to the doctor's appointment. So I apologize for that, but I at least want to cover any. Like I'm probably going to end class like at 10:40, something like that. You have to be at Grafton Hospital by 11:15. But so before I start on stacks, what do we have any questions or any things you want me to review related to the midterm for Thursday?
All right, I have a few. So one is, so is a struct in C++ closer in Java, like is it closer to like JSON? Oh, wait, not JSON. Never mind, I understand that question, never mind, moving on. Just answer.
Were you asking about interfaces? Is it closer
Yeah,
to an
like,
interface?
Is it closer to like an interface or is it closer to like an object? I know like objects are kind of.
Well, it's definitely closer to an object because a struct actually holds data. Interfaces don't have implementations. So I would say a struct is identical to a Java class that doesn't have methods in it, except that by default it's passed by value instead of address. Otherwise, functionally, it's identical. It's holding name value pairs. Really the best comparison, although it's pretty much a similar comparison, is a struct in C++ is functionally identical to a dictionary in Python. But again, dictionaries are passed by address. Structs are passed by value. So that does have a different end effect if you start changing the contents of the struct inside of a function. If it's passed by value, those changes will not be noticed outside. But if it's passed by address, they will be noticed. All right, what other?
Next one is what's the difference between like a struct and a header file?
A struct and a header file, completely different. So again, structs are just a variable capable of holding name value pairs. That's what a struct is. Header files are upgrade to prototyping functions. So if we are, in fact, I wrote one.
Isn't the header file facing above the regular CP?
Here, let me just show you this as an example. So this is from the 450 class yesterday. Unimportant, actually, we're not even doing anything super crazy. This was more of a C example. So here's my main. All programs begin and end with main. This is actually written in C instead of C++, but this explanation is the same. So I have my main method here, And then down here, I've defined a couple of other functions, right? So I have an encode rot13 and I have this index of function I wrote. But before main, I prototyped those functions. That way, when the compiler goes through, goes through here and says, ah, I see that you're going to have a function called encode rot13. This is not the implementation for it yet. It's just notifying it that these things will exist. That way, in case you bump into it inside here, before it was actually implemented, it won't throw a compile error. All right, so the old school way of doing this would have been you write all your functions in whatever order you want to write them in, and then at the top you just give the header line of they're called prototypes for all those functions at the very top. That way the compiler doesn't scream. The more modern way of doing this is you take what I have highlighted here and you suck it into a header file. So the header file ends up being kind of your self-documenting thing that says, here's the stuff that my class will have in it. I will implement it over in the class. Okay, but at the end of the day, at the top, when we say include standard io.h, for instance, when I say include card.hpp, like we've had, all that's doing is taking the contents of that file and effectively pasting it at the top of your program here. So it's ultimately going to give me something like I have highlighted there at the end of the day. But as human beings, we're separating those two into two separate files for, let's call it readability or something like that. Okay. Yeah, but so in that case, I mean, they're nowhere close to a struct. I mean, a struct is solving a completely different problem. All right.
One more.
Okay.
Delete function deployments. I kind of think we kind of did it, but we would do like something like that.
Sure. So the question is with delete, the delete function. So the idea is, so what is the delete function accomplishing? When we create a mess at home, when we're done, you know, if I'm cooking dinner and I make a big mess all over the counter and stuff like that, when I'm done cooking dinner, I'm responsible for cleaning up that mess. All right. So the delete function effectively gives memory back to the operating system after we've created memory. So if I were to write an example of that in here, I can say something like int AR10. In fact, actually, let's do it this way. We're going to say int array AR is equal to a new int array 10, something like this. So that'll create brand new memory. I'm kind of writing C++ stuff here inside of C, but let's just say that's fine. Then I'll do something like for int I is equal to 0, I is less than 10, I plus plus, AR at bucket I is equal to I times 2 for no good reason, just fill it up with stuff. And then I can go pass this array around and things like that. But when I'm done, okay, technically, I asked for this new memory. If I was writing this in C, I would actually call the malloc function to memory allocate some new memory. But at this point, I am done with it. So rather than relying on maybe a more modern well, actually it wouldn't be a C compiler, it would be the C runtime. Rather than relying on a more modern operating system that might clean up any memory that was claimed by a running application, I would come in here and say, I'm going to delete AR when I'm done. This says, I am giving back to the operating system the memory that was created to hold 10 integers. So the 320 bytes of memory that was generated right here, that the operating system flagged as belonging to me, I am now saying I'm done with that 320 bytes. You can give this to somebody else. It's no longer assigned to me. So you're taking control over cleaning it up on your own. Yeah.
So does this automatically happen after your program is running?
Does what automatically happen?
Does it automatically delete all the memory you're using in the process?
Well, okay. So it's a little bit of a loaded question. In a modern operating system, yes, it probably would take any memory that was created as part of the program that just finished and give it back to the OS. From a programmer's perspective, you don't necessarily want to rely on that.
Okay,
From
so
a,
it would be good practice to go through at the end of your program and delete everything that you use.
Yeah, well, here, the real life example, I jokingly use it in class, but it's also true. I'm making dinner at home. I make a big mess. I finish eating dinner. I walk away. Don't clean up my mess. Okay. Magically, within a couple of hours, that mess is cleaned up. Why? Because my wife came through and cleaned it up. Right? Automatic garbage collection. So
In C#, if you were doing like some forms, like you would do that automatically.
same thing. Yeah. But we would say, so over the years, I've reminded you that as programmers, we want to think about things through the lens of like how real life works. So even though I know that I can make a big mess in the kitchen and it'll magically get cleaned up because my wife will zip through the kitchen and clean it up and I'll probably hear about it, but whether I do or not, it doesn't matter. Even though I can rely on that happening, it would still be good practice for me to clean up my own messes so that I don't leave this mess for my wife to clean up afterwards, even if she would do it anyways. Does that make sense? So to your point, you would say, is it good programming practice? I would say yes. The less you rely on the operating system doing automatically for you, the better off you are, because now you're writing code that's not reliant on some sort of special, servant on the outside, but at the same time, you're also giving performance back to the operating system so it doesn't have to do that extra oversight, right? Because at home, my wife's got better things to do than clean up my messes, right? Even though she will clean up my mess. It's in my best interest not to rely on that fact. The unfortunate reality, though, is even if I clean up the mess, it's never up to her standards, so she ends up cleaning it anyways. So in practice, I clean up 92.25% of the mess. The rest of it gets sterilized by automatic garbage collection in my house. That's okay. I'm in charge of killing bugs. Anything with stingers, anything with the gift of flight, I'm your guy. So it's essential. And we've been married longer than actually probably most of you have been things. So it would be 21 years in May. Most of you are not 21 yet, right? Yeah. Yep. You're 20. Yep. So I got married when you were born. And now I'm locked in. I don't even know what medicine I take in the morning. I take whatever's in the morning bucket. That's what I take. All right, other questions? Now, along the lines of the delete thing, I probably am not going to ask you a question on the exam specifically about delete. And I certainly wouldn't take off points if you don't use delete. This is really more of what's considered good, as you pointed out, good programming practice. And I would almost always, whether it's this concept or any other one, really think back to what would be appropriate in real life. You make a mess, you clean up the mess. That's the appropriate in real life. And as Java developers, and you heard me probably talk about this in 200 and again in 250, Python's the same way. Python doesn't give us a special syntax for cleaning up our messes. So as programmers who learn to program using these very evolved languages, it's easy for us to get lazy because we never had to clean up our messes before. It was never an option for us. I go and cook dinner in the kitchen, make a giant mess, and now I'm not allowed to clean it up as much as I might want to. Those languages don't give us the tools to do it. So as programmers, it can make us a little bit lazy. Then when you get into newer, older languages like C++, which again, now the operating system's kind of playing cleanup for us, right? It'll do the heavy lifting for us so that we don't have to. But as good programmers, we should still do it. Otherwise, we risk getting into, you've heard of something called a memory leak before, where you have a computer program that has left memory over, still owns some memory, and for one reason or another, the OS doesn't reclaim it. Even though we might rely on it reclaiming it, for whatever reason, the program doesn't reclaim it. So we would consider that bad programming practice. All right, other questions or other examples you want me to look at? What about online?
Would it be possible for you to show like insertion sort on a integer array or anything?
Insertion sort on an integer array. Okay. So you want to just fill an integer array up real quick and then write insertion sort on it? That's
Yes.
Let's see. Here, I'll go ahead and do it inside of our Hearthstone thing. That way I can easily push it, if that's cool with you. Where's my driver? There's driver. All right, so I'm going to go ahead and, well, here, we already have our, we have an array being filled up with 10 random numbers. Actually, did we already write insertion sort for this guy? Oh, yeah, we did. Yeah, so we'll just walk through it. So here's our, I created an array up here with 10 elements in it. So I was showing you how macros work here. So this is the same thing as hard coding a 10 in here, but you can change it just in one place here. And anytime you use this, you have access to it. I went ahead and I filled it up with random numbers. Remember, this guy right here was our way of it was a way of seeding the random number generator. So I'm creating an integer array here that's just filled with 10 random numbers. And then I'll go ahead and I'll display that guy, and we'll see that it has 10 random integers in it. Plus, actually, we can just do our /compile here. So there's our 10 not in order numbers, right? Now remember, insertion sort, what it does is it starts at bucket 1 and says, how far up can I move this? So if I'm kind of going through this guy here, a 147, should a 147 come before a 111? No, so I'm done with that. Should a 466 come before a 147? No, I'm done with that. Should a 517 come before a 466? No, I'm done with that. Should a 512 come before a 517? No, I'm done with that. Should a 187 come before a 512? Yes, swap these two. Should a 187 come before a 517? Yes, swap those two. Should a 187 come before a 466? Yes, swap those two. Should a 187 come before a 147? No, we're done. Should a 334 come before a so on and so forth, okay? Till we run off the end of it. So if we go back over here to our insertion sort code. So here's the variable we're using for doing a swap. So that's when we need to swap something, we need to take the temporary thing, or we need to take the value we're about to overwrite, we need to preserve it somewhere. Then we can overwrite it. Then we can overwrite the original place with the value we temporarily held. The follower is our variable that allows us to follow something up the array so we don't lose our starting point. So out here, like when I said this 187 should be swapped with a 512, something needed to follow this 187 up our list so that we didn't lose track that this was our current starting point. Because when we pick up, when we finally get the 187 as far up our array as possible, the next thing we're going to tackle is this 334, then a 16, then a 945, so on and so forth. So we need to have two different variables. One that's going to go from bucket 1 to bucket 2 to bucket 3 to bucket 4, so on and so forth, all the way to the end of the array. And that one doesn't change except by going up by 1 each time. The other one allows it to follow something that we're swapping back up towards the front of the array until it's at its final location. So that's what this follower thing is. All right, so our for loop starts, cur start off at, actually, cur start would start off at 1 because we wouldn't even look at bucket 0 because there's nothing before it. So if we're looking at bucket 0, there's no way, it's impossible to do any swap because there's nothing before it. So we would start off at bucket 1, we'd go all the way to the up to in the last legal bucket in our array, incrementing it each time. We set the follower equal to whatever cur start is. So we reset the follower each time so it can potentially bounce back up the array. And then we say, well, the follower is greater than 0. So as long as we're not at bucket 0, because if we're at bucket 0, we have nothing before me to compare it to. Therefore, a swap is not going to happen. This while loop right here asks the question, should I swap the current element with the element before it? That's the question we're asking right here. So while the follower is greater than 0 and the element at the current bucket, the follower, is less than the guy before it. If both of those things are true. And remember, from a programming perspective, the important caveat here is since this is an AND, programming languages are smart enough to know that in order for an AND to be true, both sides need to be true. So if this guy is false, if the follower is equal to 0, if it's not greater than 0, it won't even try the second half, which is a good thing because the follower at bucket -1 or AR at bucket the follower -1 might not be a real place. So we're only going to actually even check this if we have a fighting chance of this AND being true, which is only going to be if the follower is greater than 0. So this says, if we should swap, then what do? We swap. Preserve the value we're about to overwrite the value, overwrite the other value with the value we preserved. And then what does the follower do? It follows. It goes up thing. We're not changing cur start. Cur start's going to keep track of where we're going to start next time. It's the follower that bounces back up the list. So this guy is going to happen over and over and over and over again, as long as the element at bucket the follower should be swapped with the guy before it. As soon as we hit our stop case, either we get to the top of our array or we shouldn't swap because the guy before me is not less than me. Then we fall out of this loop, hit the end of the for loop. The for loop increments cur start to the next guy, and then we reset the follower to the current cur start. We do that over and over and over and over again until we've run out of elements to swap up the list. So now, if we call insertion sort on our data and then display the int array again afterwards, is this our starting point? There's our sorted array following insertion sort. And that code, I'll go ahead and since I made that small change and changed it to a 1, that code is, is currently up on GitHub. So inside of driver of our current Hearthstone code, I have a lot of stuff commented out. And what we're actually doing right now is insertion sort on an integer array, as you were talking about. That makes sense? All right, what else? Go ahead. You won't have to. So the question was, is insertion sort going to be on the test? I would say no. I'm not an advocate of memorizing algorithms. So I wouldn't test you on your ability to memorize an algorithm. That isn't to say I might not ask you something on a test. I might not ask you to read code, and that code happens to do an insertion sort. And I asked you, what does this code do? Now, you wouldn't necessarily have to answer that by saying this is an insertion sort, but you might say, oh, this sorts the data, something like that. Yeah, so I think that answers what you asked. Don't memorize algorithms. You can always look those up. Our skill set as a programmer should be that we should be able to write an algorithm given it or something. Yeah. What do you mean nodes and pointers? Okay. So if I go into our node here, well, so we'll look at the header file here. So our class for a node keeps track of 2 pieces of information. So you can think of a node I mean, we called it node, but we can call it whatever we want, right? You know, it's a little garbage bag that's holding two pieces of information. I throw in the value, the payload, the integer this node holds, and I also throw in the address where the next node in the list lives. That's what these two things are. It's what's my value? Where's the next guy in the linked list? Those are those two things. If we look at the implementation of this guy, we can, you know, here's the constructor. We build a node by giving it a number. So we kind of create this little box. We throw a number into that box, and we initially set his next node to nothing. All right. And then we just have our getters and setters and stuff like that for getting the next node and setting the next node and that kind of stuff. So at the end of the day, if we look at our pictures here, this is like our linked list. So this is a node. This is a node. This is a node. These are each instances of that node thing we just talked about. So this node right here has a payload of 4, and it has a next node right here, which is a memory address, which points to the next node in memory, which is another actual node. And this guy has a payload of 7 with a next node that points to a whole nother node in memory, which is actually a node, which has a payload of 13, so on and so forth. Make sense? Okay. Well, actually, if you look at data structure books for C, which would probably be the way data structures were originally taught, which is before objects, that you would do it as a struct, right? It would just be a struct that holds two name value pairs. One is the current value, the payload, and the other one is the next node. Easier, I mean, it's a wash. It's a wash. Classes give you more protection because we're saying we're gonna give read-write access to the node, to like the next node, but we're gonna give read-only access to the payload. We can do that with a class. You can't do that with a struct. A struct, you say, look, here's my two values. I have a payload, I have a next node, and you can read from it, you can write to it, you can do whatever you want. It's an open thing. Yeah, so questions like, is one thing easier than another, really are loaded questions, because I mean, it just depends. And if you're writing this in C, it doesn't matter which one's easier. C has structs, C does not have objects. So objects are off the table. The more modern way of doing things is through an object. Maybe I would make the argument that objects are actually more complex, but give you more flexibility, give you the ability to set security and stuff. All right. What else?
I have a question about header files.
Sure.
If you had everything either private or public, would you need to write down the other one and just leave it empty, or would you just have the one that everything is in?
Okay, so you're saying inside of a header file, like over here, I have both a private and a public section. You're saying if everything was public, for example, would I even need to write the private section? No. If you had nothing in this private section, if both of those things were down in the public section, you would not have to have a flag here that says private. The only reason you have that there is to dictate that here are the private members of this class. If you have 0 of those, you don't just have to randomly put the private colon thing there.
Okay, perfect. Thank you.
No. Because if you don't make them private or public, the default is something called friend, which means that as long as it's in the same directory, you'd have access to it. But that would be considered bad programming practice. So practically speaking, you should make it private or public. And good programming practice should indicate that it would be fairly rare for you to have a class that does not have some private members. If everything is public in a class, so let's kind of complete a loop that we talked about today so far. If everything was public in a class, I would maybe question why you're not using a struct. The only answer to that would be if some of the public members were functions. If they're only fields, if they're only variables, you have a class that just holds 5 public fields, that's a struct all day long. But most of our objects should have a private section. They should have a public section because that's just good programming practice. You want to have everything as locked down as possible and then loosen the reins as you need to. Don't take the easy way out and just say, everything's public because that's convenient. I get it. Makes a lot of sense. Not going to allow you to keep a job very long when you get into industry. All right, other questions? Okay, so remember the exam is on Thursday during class time. So we won't meet in class, but I'll be here on campus. I'll be in my office. So if you happen to come to the classroom to take it and have a question, you can come get me. I'll be on Slack during live. I can always jump on Zoom if you have a question. I don't think there's going to be a problem with questions or something, but the bigger issue might be if you have a problem opening the exam or your internet died or something and you need me to reset your exam. I'll be there to do it. So everything should go smoothly. So it's during class time on Thursday. If some people who have accommodations for like extra time or something like that, that's fine. Your exam will automatically have like the extra time on it. If your plan is to take it at a different time period, in case, if you have 2 hours to take the exam, for example, and you have a class immediately following that, just send me a message and we'll arrange for that. It won't be a big deal. Blackboard lets me set. I think I know how that part of Blackboard works. So it's pretty easy to do it on a per user basis, but we'll make it work. Okay, I will see everybody. I might see you on Thursday, but otherwise I'll see you on Tuesday.